Welcome to our channel, where today we're diving deep into the fascinating world of plasma energy, a topic that holds astonishing secrets you might not have heard before. Plasma is often referred to as the fourth state of matter, existing beyond the traditional solid, liquid, and gas states. It's all around us, in the stars, the auroras, and even in the fluorescent lights above us. Yet, its potential, particularly in the energy sector, remains vastly untapped. Let's explore 5 shocking truths about plasma energy that might change the way you perceive the future of energy. Our journey begins with understanding what plasma truly is. Though invisible to the naked eye on its own, plasma is a hot, ionized gas composed of free electrons and ions. This charged soup conducts electricity and generates magnetic fields, setting it apart from the other states of matter. You might wonder why plasma isn't more commonly discussed, despite its ubiquitous presence. That's because its application and potential remain complex, ensconced in scientific exploration and technological hurdles. But as we peel back the layers, you'll see why plasma energy could be pivotal in reshaping our world. First, let's uncover the truth about fusion power, an energy source that mimics the sun's own processes. Fusion has long been hailed as the holy grail of energy because it promises an almost limitless supply without the carbon footprint of fossil fuels. By harnessing plasma, scientists aim to replicate the fusion reactions that fuel the stars. The challenge, however, lies in containing the plasma at extremely high temperatures and pressures. This task involves sophisticated magnetic confinement techniques, such as those employed in tokamaks, which are donut-shaped devices designed to sustain controlled fusion reactions. Despite these challenges, significant progress is being made, and we are closer than ever to achieving viable fusion power, which could potentially meet global energy needs without environmental damage. Next, let's delve into the role of plasma in space exploration. Plasma thrusters are revolutionizing how we think about propulsion in space. Unlike traditional chemical rockets, these thrusters use plasma to create thrust, offering significant efficiency and speed advantages. For instance, they've already been used successfully in satellites for station keeping and in deep space missions. The promise of faster, more sustainable space travel beckons, thanks to these innovative propulsion systems. This advancement could open new frontiers, making the distant reaches of our solar system more accessible than ever before. The third truth lies in environmental restoration. Plasma technology is being explored as a powerful tool for pollution remediation. Through processes such as plasma gasification, waste is transformed into usable energy, drastically reducing landfill contributions and harmful emissions. This method effectively breaks down complex molecules, making it a potent solution for managing toxic waste. It offers a cleaner, more efficient way to deal with humanity's burgeoning waste problem, inching us closer to a more sustainable existence. Our fourth insight reveals plasma's potential in healthcare. Plasma medicine is an emerging field that utilizes cold plasma technology for medical applications, including wound healing and cancer treatment. Cold plasma is effective in sterilizing surfaces and tissues without damaging them, promoting faster recovery. Its ability to target cancer cells without harming healthy ones is particularly promising, offering new hope in the fight against one of humanity's most formidable diseases. This application is a testament to plasma's versatility and transformative potential beyond conventional uses. Finally, we must address the hurdles and implications of plasma energy. Despite its promise, the widespread adoption of plasma technology faces significant scientific and economic barriers. The cost of establishing the infrastructure for plasma-based fusion or waste management is substantial, and the technology itself is still under development. Moreover, the potential geopolitical impacts of an energy paradigm shift from fossil fuels to plasma-based systems could be profound, requiring careful navigation by global powers. Plasma energy may well reshape economies and redefine power dynamics on a global scale, raising both exciting possibilities and daunting challenges. In conclusion, plasma energy holds transformative potential across multiple domains, from how we produce power and explore space, to how we fight diseases and manage waste. These shocking truths reveal it to be a cornerstone of future innovations. However, realizing its full potential requires continued research, investment, and collaboration across scientific, industrial, and political spheres. As the quest for sustainable, efficient, and clean energy continues, plasma stands at the forefront, a beacon of hope and a testament to the boundless possibilities of science and human ingenuity. Thank you for joining us in this exploration, and and we look forward to unveiling even more fascinating discoveries with you soon.